Welcome to Team Voltron. It's another season of Deepracer. Looking forward to reconnecting with our fans. Welcome and enjoy. All right, so I mentioned in an earlier video, I wanted to go back to basics, really understand how the reward function is working. Now, instead of training on one of the competition tracks, which are very complicated, takes a long time to train, I decided to focus on the oval track. Yes, the oval track is kind of boring, simple, but it's a great place to learn. So what I noticed was I started asking myself, all right, what's the fastest possible speed I can go around this thing? Um, and I looked at the turns, right? How fast can I go around this turn? Now, there are some resources and some web pages, some websites and Medium articles that talk about how you can calculate the fastest possible speed. And that's all well and good, but I wanted to keep it simple for today. And I was thinking to myself, well, let's take a look at the angles, right? Let me understand what these angles look like. So using Python, using the quiver function, I drew out the angles from every waypoint, looking forward just to the next waypoint to see what it looks like, right? So the idea is when I turn left, I want to turn left at, let's say, 10 degrees all the way around the turn, right? That's what I want to do. When I drive in real life, that's basically what I do. But what I found was interesting was there's some noise here. Look, there's variation here around waypoint 49. And then here is 68, actually 66 to 67. The arrow points the other way, right? So this data is dirty, right? There's the waypoint is imperfect. There's there I want to say mistakes, but there's glitches in the waypoints, right? So if you're doing a waypoints rewards function, you gotta really keep an eye out for this kind of stuff, right? Because once the car gets here, it could get very confused. So so anyway, you follow the blue arrows. The car ideally would be following some kind of path around the track like this. All right, so with this, I said, well, let's calculate the math, right? Let's calculate the angles, I mean. So what did I do? Well, I calculated the angles and I come over here, put this into a spreadsheet. These are the angles that I calculated at each of the waypoints, 25 through 40, 45, and took the average, right? So the average was 10.9 according to this. So just like I was saying, like, yeah, let's just see if the car can just turn 10 degrees the entire time. So what's the next step? Well, the next step for me was to go over to the Actionspace, right, and define that. So I'm going to go straight, steering angle 0 to go straight, and have a couple of speeds, and then I have a turn and a couple of speeds. So I want to try this out. So I said, all right, this is cool, right? Now I want to have a really simple reward function. And I asked myself, can this really work? You know, let's just return the speed, right? I tried it with return 1. That also works, but I want to really pump the speed. So the reward function is simply the speed of the car. So I started training, let it run for a few hours, and here's what I get. Car is going around the track, right? Simplest reward function possible, just the speed of the car. I couldn't believe it. I was like, really? I worked hours on my reward function in the past, staying up late nights, trying to figure out all the math, looking at Medium articles, but reward return speed just does the trick. Now, is it going to win the competition? No, but it's a great start. And look at this, the car just goes around the track, no problem. And really opened my eyes. Like, man, I got to really simplify my reward function. My old reward function was like 200 lines long, something crazy like that. Spaghetti code, all messy. Try the optimizing the waypoints, right? Like, it was a mess. This reward function right here. return the speed. That's trusting the algorithm. That's trusting reinforcement learning, the policy to figure out what the best choices are, right? All right, so I let this run for a couple of hours and then I ran evaluation. And this is what I'm getting. I'm getting lap times of 10.4 seconds, 9.9. This one off track over here, I guess at the very end. 10.2, 10.1, off track. All right, so it goes off the track half the time, more or less. But let's see, 9.6, that's probably the fastest lap here, which is, I think it's pretty decent, pretty good. But then I got curious. I said, what does it look like my training laps, right? What do my training laps look like? So I came over here again to the training, back to the training notebook and said, all right, let's take a look here. So when I look at the completed laps, the smallest number of steps, which is going to correspond to the fastest time. Look at this, 8.8 seconds. That's pretty good. That's pretty good for me anyway. 8.8 seconds around the track with this Actionspace and this very simple reward function. And we really could maximize the reward function at this point, right? So it's really amazing how if you pick the right Actionspace, think about the angles, you can really carve off a lot of time before even getting to the reward function. So there you have it, folks. 8.8 seconds is the fastest, let's say, theoretical time. I mean, I would have to play the lap lottery and submit this to evaluation hundreds of times to get this. But it is feasible to get this lap time with this model, believe it or not.
There you have it, folks. Team Voltron. Stay tuned for more. Make sure to subscribe and click that like button if you want to see more of this content.